Battery technology for electric vehicles is in a constant state of evolution, but truly transformative breakthroughs are rare. For years, Tesla's 4680 battery was portrayed as one such breakthrough, yet paradoxically, it also became one of Tesla's most controversial technologies. After being announced with enormous promises, the 4680 cell appeared to stall, showing up only in the expensive Cybertruck and failing to scale as expected. Many industry observers even concluded that the technology had failed. Today, that narrative is changing. With major advances in manufacturing, especially Tesla's long-struggled dry-electrode process, the 4680 battery is re-emerging not as an experimental concept but as a strategic pillar of Tesla's future. Its confirmed return to the Model Y signals that Tesla has finally overcome its biggest technical hurdles. More importantly, it reveals how the 4680 battery has evolved from a bold engineering vision into a tool for cost control, supply chain resilience, and long-term independence. Hello, my friends. Welcome to the channel. Great to have you with me. I'm Mike. Stick around by subscribing. There's a lot more interesting stuff coming, and my goal is 100 subscribers this week, so please help me reach that goal. Thanks. Tesla first unveiled the 4680 battery at Battery Day in September 2020. Elon Musk described it as the largest leap forward in lithium-ion battery technology to date. Crucially, Tesla was not simply introducing a new battery cell, it was proposing a complete redesign of how batteries are manufactured, assembled, and integrated into vehicles. 4680 refers to the cell's physical dimensions, 46 millimeters in diameter and 80 millimeters in height. This made it significantly larger than the widely used 2170 cells. While the size increase itself reduced the number of cells needed per pack, the real innovation lay in the design philosophy behind the cell. Contrary to some misconceptions, the 4680 is still a lithium-ion battery. It continues to use lithium along with nickel and small amounts of cobalt. What differentiates it is its tabless design, which eliminates the traditional metal tabs that connect electrodes to terminals. In conventional batteries, these tabs act as bottlenecks for current flow and heat dissipation. By distributing current evenly across the electrode surface, Tesla reduced resistance, heat buildup, and degradation, allowing for higher power output, faster charging, and longer lifespan. At launch, Tesla cited an energy density of around 272 watt-hours per kilogram, placing the 4680 among the most energy-dense mass-produced battery cells in the world. Combined with structural battery packs, fewer components, and simpler assembly, the 4680 was projected to dramatically lower costs. Despite the ambitious vision, reality proved far more difficult. Tesla began pilot production of 4680 cells in late 2021 at its Cato Road facility in California. This line was designed not only to produce cells, but to teach Tesla how to manufacture them at scale. For nearly 2 years, most 4680 cells were reserved for internal testing. The biggest challenge was Tesla's dry-electrode manufacturing process. While Tesla successfully implemented dry electrodes on the anode side, it struggled to do the same for the cathode. As a result, early 4680 cells relied on a hybrid approach, dry anodes paired with traditional wet-processed cathodes. This compromise undermined many of the promised advantages. Wet electrode production requires toxic solvents, massive drying ovens, and large factory footprints. Instead of cutting costs early, 4680 production was expensive, inefficient, and prone to defects. Reports pointed to cracking materials, poor adhesion, low yields, and inconsistent quality. In some cases, energy density was even lower than that of older 2170 cells. Elon Musk openly acknowledged that scaling dry electrode technology was far harder than expected, describing it as extremely sensitive to small deviations. These difficulties fueled skepticism across the industry. Given these challenges, Tesla had little choice but to limit deployment of the 4680 battery. The Cybertruck, with its high price, low initial volume, and entirely new architecture, became the ideal testing ground. Its margins could absorb higher battery costs, and its production ramp did not require massive immediate scale. In contrast, high-volume vehicles like the Model 3 and Model Y could not risk adopting unstable battery technology. Even minor issues could impact hundreds of thousands of vehicles per year. As a result, from 2023 onward, the Cybertruck became almost the sole vehicle using 4680 cells, reinforcing the perception that the technology had failed or reached a dead end. The turning point came with Tesla's confirmation that it has finally achieved dry electrode manufacturing for both the anode and cathode. In its Q4 update and fiscal year 2025 report, Tesla stated that 4680 cells are now produced entirely using the dry process. Elon Musk described this achievement as a major breakthrough in lithium-ion battery manufacturing. By eliminating solvents and drying ovens, Tesla can now reduce factory floor space by up to 90% and significantly cut energy consumption per cell. For the first time, the 4680 battery has become cheaper than the 2170 battery on a per kilowatt-hour basis when produced in the US. The dry process also improves performance. With binder content reduced to roughly 1 to 1.25% compared to 3 to 5% in conventional cells, more space is available for active materials. This results in a 5 to 10% improvement in energy density without changing battery chemistry, an approach that is lower risk and easier to scale. Durability improves as well. Without solvent damage and high-temperature drying, electrode particles maintain their structural integrity. Internal testing suggests that new generation 4680 cells can retain around 90% capacity after 2,000 charge cycles, making them highly attractive for long-range vehicles and second-life energy storage. Dry electrode technology enables a new manufacturing model. Instead of massive gigafactories, Tesla can deploy smaller, high-throughput microfactories near vehicle plants. According to Musk, optimized lines could deliver up to 10 times higher throughput, with total battery costs potentially falling 20–50% depending on application. This manufacturing flexibility gives Tesla an advantage that competitors still locked into wet electrode processes will struggle to replicate quickly. Tesla has now confirmed that the 4680 battery will be used again in the Model Y. This is not the first attempt. Limited Model Y variants with 4680 cells appeared between 2022 and 2023, but were quietly discontinued as Tesla prioritized Cybertruck production and struggled with supply constraints. Some believe the current return is driven by oversupply of 4680 cells due to weak Cybertruck demand. While that may be partially true, Tesla has made its broader motivation clear: supply chain security. A significant portion of US.sold Model Y vehicles still rely on batteries sourced from China, primarily from cattle. While these batteries are affordable and reliable, they carry geopolitical risk. Trade tensions, tariffs, or export restrictions could rapidly erode Tesla's cost advantages. In this context, the domestically produced 4680 battery becomes a strategic safeguard. It may not always be the cheapest option in isolation, but when tariffs, incentives, and long-term risk are considered, it offers stability and control that external suppliers cannot. The 4680 battery was once marketed as the key to a $25,000 Tesla. Today, its role is different. Rather than immediately slashing vehicle prices, it helps Tesla reduce dependence on global supply chains and maintain flexibility in an increasingly uncertain political environment. What do you think about Tesla 4680 battery with new upgrade? Let us know your thoughts in the comments.